Hi, welcome to Chapter 10, Statistical Quality Control. And we have a gentleman here in a red hard hat who is inspecting, looks like some stainless steel coming out of a mill off a roller, and he looks like he's inspecting it for defects. And if he counts up the number of defects, he can produce a quality control chart. And these things look like this. Time flows in this direction. We have a center line. We have some upper control limit and some lower control limit. And we plot our parameters of interest wherever they might lie on this axis here. And we just connect up the dots. And based on some fairly simple methods, we can determine if the process is in control, which this one appears to be, or if we find a point that's outside our upper and lower control limits, the process is out of control. We can determine if it's heading one direction or the other, and we can make adjustments to make sure we have fewer defects. So that's the idea with statistical quality control. We're taking samples, we're measuring them in some way, and plotting the results. So we're going to look at solve problem number 2, and we're going to be calculating sample mean, do an X-bar chart, and a range chart. And the reason we're going to do these two is we have data which is based on measurement. So suppose this machine is producing ball bearings, and the target for the ball bearing is 10 millimeters across, and we sample 4 ball bearings. The first go around we have one that's 10.2 millimeters in diameter, and one that's 9.9 millimeters in diameter, and one that's 9.8, and so on and so forth. Now, if we were looking at the number of defects per ball bearing, we would be using a C chart or a P chart. But in this case, since we have measurement data, we're going to be looking at sample mean and range. So let me just go back to that. The question is the process in control? And the only way to determine this is to actually do the calculations to determine the center line, the upper and lower control limits, and plot the data against that. So we'll do that over in Excel. So what I've done in this first part of this chart is I have my sample data right from the example, and I'm going to calculate the average for each of these to come up with my X-bar values. So I just use the average function, average of those values, and I'm going to fill right across so the average goes there. And I can take the averages of the averages, so the X bar will be the value we create. So let's do that, equals average, and again of all of these. So that'll be my center line, 10.04. I also want to draw a range chart. So the range is just the maximum of these 4 values minus the minimum of these 4 values, and you can see the range is there. And we'll take the average of those as well to come up with a center line, R bar, average of these values. So I have my center lines for my control chart, actually control charts. I have X R bar, the average of the averages, and I have R bar. So I'm going to draw 2 control charts. These are going to be my center lines, and these will be the values on those 2 charts. What we need are the upper and lower control limits. So what I'm going to do is I'm going to grab those values. You'll see them in the spreadsheet here, but where did they come from? Well, let's go over to our textbook. We can see that if we're doing an X chart, we have our upper control limit is X bar, our center line, plus A2 times R bar. And again, we calculated R bar. A2 comes from this column here, and we had 4 observations in the sample, so our value is 0.73. And the lower control limit is X bar minus A2 times R bar. So those ones are easy to find. Additionally, we can use the same chart for coming up with the upper and lower control limits for R bar. And we use these two columns here. So we have 4 observations in the sample, so the lower control limit is 0 and the upper control limit is 2.28. So this comes right from table 10-2 in the textbook. Okay, so there we have our original data. We have the table of the factors, and we're going to bring it all together in our Excel spreadsheet. So I've got my A2 value, 0.73 from the table, my D3 and D4 values of 0 and 2.28 from the table. Now, my upper control limit, you can see the formula up here, is just my X bar center line plus 0.73 times 0.52, my R bar value. And likewise, the same formula here, except I'm just subtracting the second factor. My R chart values, I've got 2.28 times my R bar, and 0 is this 0 value times my R bar. So I now have everything I need to know, and we'll plot our charts. So this is our X bar chart, and you can see the values there. Now we could have just looked at the data in the spreadsheet, but it's nice to plot these things. So this is my upper control limit, my lower control limit. This value here is X bar bar, and these are the individual X bars for sample 1, X bar, whoops, for sample 2, and so on. And we can see the values have a nice pattern. They're on both sides of the center line. There doesn't appear to be any patterns. We don't see trends going up or down. We don't see large runs of values above or below the line. We're not seeing wild fluctuations, those kinds of things. And obviously none of the points are outside the upper and lower control limit. So this process is in control. And we can verify that by checking our R chart. And again, what have we got on the R chart? Well, we have, there's our range, our R bar. This is the individual ranges and the average range. This is our lower control limit, which we said was 0. This is our upper control limit up here. And again, we're not seeing trends one way or the other. The variance is staying fairly static. So this process is in control. The X bar chart and the R chart are used together, so that's why we plot both things at the same time. So the process is in control based on the data we have there. And that ends the first video for Chapter 10, Statistical Quality Control.